Okay, question 13 is a nice big integration question. It's a 10-mark question, which often puts people off, but if you break it down and work through it a little bit at a time, it's not actually that scary. We've got two curves or two equations, two lines that we're dealing with here. And this area here, this R region here, is actually made of two areas. We've got the area between these two numbers, which is the area under the curve, and we've got this triangle here. We know that this point is E. We know that value there is E. We're going to need to work out this point. We're going to need to work out the equation of the line probably in order to even start the integration. So let's think about finding the equation of the line. What do we know about this line? It says that the line L is a normal to C at this point. So that means that we've got the tangent to the curve has the negative reciprocal of the gradient of L. So if we can find the gradient of the tangent of C when x is equal to E, we're going to be able to find the equation of this line because we know a point on the line, we know P. So that's the initial first few steps. We're going to find the gradient function. We're then going to find the actual value of the gradient of the tangent line at E. We're then going to use that value to find the negative reciprocal because that's going to be the gradient of L. And then we're going to use y minus y1 equals mx minus x1 to find the equation of line L. So let's start off by differentiating of the actual function. Okay, dy by dx. Differentiating this. Now this is a product, so we're going to use the product rule, which says differentiate the first one, leave the second one alone. That's going to be just 1 times ln x. Then plus, leave the first one alone and differentiate the second one. Leaving the first one alone is x. When we differentiate ln x, we're going to get 1 over x. And x times 1 over x just cancels down to 1. So the derivative of the function is actually just ln x plus 1. At the coordinate E, the gradient of the line, the gradient of the tangent, is going to be ln E plus 1. Now the natural log of E is just 1 because natural log is log to the base E, and log to the base E of E is 1. When the bases match, when the base matches the value that you're logging, the answer is always 1. So that means that this is just 1 add 1, which is the gradient value of 2. So that's the gradient of the tangent line. And it's good to label things. It helps you keep track of what's going on. It helps you process your thoughts. And it helps you stop making silly mistakes as well. That's the gradient of the tangent. So gradient of normal, which is L. So our line L. That's a rubbish L. Is going to be negative a half, the negative reciprocal. We also know that P is on L. So we can use y minus y1 equals mx minus x1 to get the equation of L. So that's y minus e, and don't worry that we're having to use e's, that's fine, that's okay, is equal to negative a half times x minus e. I'm going to times by 2, 2y minus 2e is equal to minus x plus e. Let's move everything over to the left. So we're going to have x plus 2e take away 2y, sorry, take away 3e equals 0. So that's the equation of L. And it's nice if you underline it, if you show it off, then it helps the examiner find it, especially on these big mark questions. So why is that useful? That's going to allow us to work out this point here. At that point, the y coordinate of line L is equal to 0. So let's label that point, say, A. And now let's tell the examiner that we're going to find A. So at A, y is equal to 0 on this line. So we've got x plus 0 minus 3e is equal to 0. So x is equal to 3e at A. So the equation of the coordinate of A is 3e 0, which means that point's 3e. That's now going to allow us to find the area of this triangle, because as well as knowing that this point here is E and this is 3e, we also know the height of the triangle is E, because the y coordinate is E. So we've got a triangle got a right angle triangle that has a height of E. It goes from E to 3e, so it has a width of 2e. So the area of that triangle is going to equal half times the base times the height. The 2's are going to cancel, and that gives us an area of E squared. So that area is E squared. So that's half the job done. We've already found a part of the area of the region. Now we need to find this area here. We know the equation is x ln x. We're going to have to do that by integrating because it's a curve. So we're going to want to integrate between some value that we don't know and e, the function x ln x. So let's next find that coordinate b. Now at that coordinate, the y value of the function of c is going to be 0. So to find b, the y is going to equal 0 of x ln x. So we need x ln x to equal 0. So that's when either x is equal to 0, which is actually this point here that we don't care about, or ln x is equal to 0. Ln x equals 0 when x is equal to 1. So b's coordinates must be 1, 0. And that tells us we're integrating between 1 and e. So this is what we're concentrating on next. We're integrating between 1 and e, x ln x dx, to find this other grey area here. So let's do that down here. Integrate 1 to e of x ln x dx. Now we've got a product here, so we're going to integrate this by parts. This is a perfect example of an integration by parts question. Normally, and if you remember the formula for integrating by parts, we have uv dash is equal to uv minus the integral of u dash v. So we need to differentiate one of these terms and integrate the other. The one we want to integrate normally, the one we would normally want to differentiate is the x term, is the polynomial, unless, the rule of thumb is, unless there's a log involved. And if there's a log involved, that's going to be the thing we want to differentiate. So that's going to be my u, and the thing we're going to integrate is going to be the polynomial, the x in this case. Now you can do this in your head, you can just start, sorry I missed out a minus sign there. You can do this in your head. It's much easier to get it down on paper, to write down what u is, what u dash is, what v dash is, and what v is. And then you can literally just write them into the formula. So we've got that u is ln x, and we've got that v dash is x. U dash is going to be the derivative of ln x, which is 1 over x. V is going to be the integral of x, which is going to be x squared over 2. And then, as I said, we can just write this into the formula. So the integral between 1 and e of x ln x dx is going to be uv, so that's ln x times x squared over 2, so x squared ln x over 2, minus the integral of u dash v, which is going to be 1 over x times x squared over 2. I'll write this out properly. This is going to cancel down. We've got an x on the bottom and 1x on the top, so that's going to cancel to just x over 2. And now this can be integrated. That's between 1 and e. Integrating x over 2 is, and we can introduce our square brackets now. Integrating x over 2 is going to be add 1 to the power, divide by the new power. So I'm dividing by 2, but there's already a 2 there being divided, so that's going to become a 4 between e and 1. Right, that's all done with the integration now. So next we're going to substitute the values in. We're going to have e squared times ln e, which we've already said is 1, so that's just going to be e squared over 2, minus e squared over 4. Take away what we get when we sub 1 in. When we sub 1 into here, we're going to have 1 squared times by ln 1. ln 1 is 0, so this term is going to become 0. And when we substitute 1 into here, we're going to have 1 squared over 4, so a quarter, negative a quarter. Tidying that up, e squared over 2 minus e squared over 4. Well, if you think about a half minus a quarter, that's a quarter. So we've got a quarter e squared here, so that's e squared over 4. Minus a quarter, so that's add a quarter. So that's my answer to that other region, the other area that we were looking for. That grey part here is e squared, e squared over 4 plus a quarter. We found the yellow bit earlier, we found that that was e squared. So the total region are, make a bit more room. So finally, is going to be that e squared that we had from the triangle plus e squared over 4 plus a quarter. So this is going to be 5 quarters e squared, so 5 quarters e squared plus 1 quarter. And if we go back up to the top to check how it wanted the answer, told us what form it was going to be in, we've got a and b being rational numbers, so that's exactly what we've got. We've got a is 5 over 4 and we've got b is 1 over 4. There's our a, 5 over 4, b, 1 over 4.